Hello, my name is Tyler Wollmuth, and I'm the Assistant Materials Engineer for North Dakota DOT. Today, I'm going to be going through a hot mix asphalt update for you as part of your North Dakota DOT Technical Certification Program training. So I'll start out with our construction program that's planned for 2025. As you can see on the chart, our 2025 construction budget is down a little bit from the previous 3 years and puts us more in line with what we spent as a DOT from 2017 to 2021. An HMA update for the state. We bid 878,000 tons of asphalt in 2024. Of that amount, 68% contained some level of recycled asphalt pavement or RAP. And the average RAP in our mix designs for this year was about 18%. Just to go through what items that we bid in 2024, we bid approximately 51% FAA 43 and FAA 42. And about 49% FAA 45. The state of North Dakota or the DOT converted to just using 3 super paved bid items, starting with the 2024 spec book. The binder grade that was used in 2024 consisted of about 15% 58S minus 28, 11% 58S minus 34, and about 74% 58H minus 34. We've been using more of the 58 minus 34 oils in the past 2 years as a result of our HMA selection guide. Density results for 2024 were improved from the previous year. So our average mainline density this year was about 94.0. As you can see, that's the first time that we've broken the 94 threshold. And our longitudinal joint density averaged 92.4, which is the highest that we've seen since we've started specifying longitudinal joint density. Incentives that were paid out to contractors in 24 included about $450,000 for ride incentive. Our average MRI on the projects that were checked for ride was about 40.3. And our mainline density pay factor this year was 102.5%, which means we paid more than 100% on average for the hot mix that was put down on DOT projects. The HMA selection guide that I mentioned earlier was updated for 24. We made some slight changes to the binder grades that were used to include more of the 58 minus 34 oils. This guide is used by us at Materials and Research when we do an asphalt recommendation, as well as being used by the districts that design their own preventive maintenance projects for asphalt. Some of the pilot projects that we completed in 24 include intelligent compaction, paver mounted thermal profiler, and percent within limits. Density profiling, or DPS, was completed on 2 projects in 2024, including the entire North Dakota 14 project, which I'll talk about later. Pilot projects that we have coming in 2025 are listed on the screen. We have intelligent compaction, paver mounted thermal profiler, percent within limits, and we also have a machine guidance milling project that we're planning for this year. That would be the first one of its kind in North Dakota. E-ticketing has been successfully used for the past few years and was used on about 11 projects during the 24 construction season. The special provision allows for e-tickets on all types of projects or all NDDOT projects. The DOT uses a portal by Haul Hub, and we are planning full implementation of e-ticketing by 2026. The North Dakota DOT was awarded approximately $32 million for a low carbon transportation materials grant. This will be used in our state to develop low carbon solutions in asphalt and concrete and help us develop environmental project declarations or EPDs for the materials that are used in our state. We're also part of the Federal Highway Climate Challenge. This is similar to the LCTM and is being used to put on training. We also hired the National Center for Asphalt Technology to help us develop EPD generation for North Dakota asphalt plants and materials. And if you work for a contractor in North Dakota and you're reached out to by Kaylin Kautzman, please return information to her on your plant so that we can start working on EPDs for our state. So I'll highlight a couple of spec changes that we're planning for the 2025 book. We have pretty minor changes this year compared to some previous years. One change we're looking at is the coring for density. It currently says full depth cores will be taken in our spec book, and that will be changed to allow for a shallower depth core for density. We also have a change to the way that we have contractors provide calibration information for the QC and QA lab equipment. Next, I'm going to talk about our BMD test section project. This is part of a transportation pooled fund that we joined a few years ago called Demo to Advance New Pavement Tech. And we're in the highlighted phase of that project, which is to build balanced mix design test sections for field verification of the performance tests that we've been running. Prior to this year, we did benchmarking of our North Dakota mixes in 2022 and 2023. And once this project is wrapped up and all the testing is done, we'll look at kind of the results of that and start developing BMD specifications that we hope to implement through shadow projects and pilot projects in the future. So I'll go through a little bit of how we developed this project. Like I said, we benchmarked mixes for the last 2 years. So all of the asphalt paving projects that were put down by North Dakota DOT were brought into our lab and tested for rutting and cracking. We identified our distresses as rutting and cracking, and we identified the BMD tests that we were going to run as the ideal RT, which is a rutting test, the ideal CT, which is a cracking test, the Hamburg wheel tracker, which is a rutting test, and the DCT, which is a cold weather cracking test. So those are the 4 tests that we primarily run in our lab when we talk about BMD tests. We created a stakeholder team, which I'll cover more in a minute. We identified challenges with our state that make us different than maybe other areas of the country that have tried this. We developed plans and specifications. We bid the project in February of 24. We did the mix design testing in August of 24. And we constructed test sections in September of 2024. So the BMD stakeholder team consisted of contractors in North Dakota, aggregate suppliers, testing labs, a North Dakota DOT, Dakota Asphalt Pavement Association, our partners on this research project, which was NCAT, and we had representatives from Federal Highway that also attended and took part in the meetings. So there were several topics that were brought up during these stakeholder meetings by contractors in our state. One request was to make test sections that were at least 1,500 to 2,000 tons of production before changing to a different type of mix. They wanted us to keep the variables to a minimum. They wanted portable plants, typically only have one main asphalt liquid tank. So they wanted to keep the asphalt types to a minimum as much as possible. And they brought up that crushing extra material like crusher dust for mixed design variations would cost the DOT a lot of money in the bidding process. Also, as part of the stakeholder group, we discussed what type of project that we would be doing. Thermal cracking is definitely our main distress type and concern. So we thought that doing just a thin lift overlay would not give us the result that we wanted. As far as cracking, those transverse cracks reflect through typically a year after paved. So we decided on a cement treated FDR, which included widening, which was 4 inches of hot mix asphalt on 10 inches of cement treated base. We settled on 8 test sections for this project that came partially from other projects that NCAT was a part of prior to ours. And it came from the way that we laid out this project and the way that the contractor would put down the mix and kind of phase their operations. So each of these 8 sections is 2 miles in length and 1 lane. We limited it to 2 binder types shown on the screen. And our variables were basically just the amount of binder that was going to be in the mix, and then adding wrap in 2 sections. So we were going to shoot for our typical optimum binder content, adjust that up and down by about 0.5%, and then add wrap to one of those. So the aggregate properties remain the same throughout the project. The gradation remained the same. Our FAA super paved grade remained the same. So we tried to limit the variability as much as we could. So some project details. Like I said earlier, this was bid in February of 2024 at a cost of about $21 million. The project was constructed this summer, and it was a 21-mile full-depth reclamation with widening, pipe replacements, cattle pass replacements, subcuts, milling, and paving. So there was a lot going on in this project that had to happen and get completed before the test sections were even looked at. So the test sections were put in the plans this way. We required 2 mixed designs, one with virgin aggregate and one with wrap aggregate. The optimum AC that was turned in by the contractor at mixed design was about 5.6%. The contractor was asked in the plans to provide 100 pounds of each of the 8 test section mixes to DOT so that we could run our rutting and cracking tests at mixed design. So the 4 asphalt contents are shown there at the screen and the 2 different AC grades. So those are the 8 mixes that we received in our lab in Bismarck. So we started testing that mix and ran through with Ideal CT, Ideal RT, and Hamburg wheel tracker. We did not see the variability that we were looking for on the Ideal CT, which is our cracking test. We thought that range was a little bit close together for what we were looking for. However, the rutting tests did show a fair amount of variability with that Ideal RT range shown there. And we had Hamburg wheel tracker rut depths that ranged from 2.5 to 12.5 millimeters. So the 2 specimens shown on the picture are 2.5 millimeters on the left and 12.5 millimeters of rutting on the right. So that was our least rutting and our most rutting of the 8 sections. A couple things that we noticed at mix design, this mix seemed to be a little bit on the dry side. And we were taking that into consideration when looking at our cracking test range. We were looking for more variability than 38 to 74. So we thought with the way that the mix looked dry that we could probably still get what we were wanting when we started paving out on the project. So after mix design was completed, we worked with NCAT at Auburn, Alabama on this, and they had said that they would bring their mobile lab from Alabama up to North Dakota. So they moved their mobile lab up here in September, and it was placed at the Sterling County Highway Shop, as seen there in the picture. I have to give special thanks to Zane and Bizwajit, who came up from NCAT to do the testing, and Travis Walbeck for bringing the trailer from Alabama up to North Dakota, as well as taking it home when they were finished. So once the lab was in place, the contractor was getting close to starting on our project. One advantage we had on this project is that the contractor was going to be paving on a County Highway 10 prior to paving on North Dakota 14, and they'd be using the same mix, same plant setup for both. So we were able to go out and actually sample mix on the county project in production and run some testing on that to see where we were at. They also paved the bottom lift of Highway 14 in early September prior to the test sections. So the test sections are just in the top lift of asphalt. And one thing that was changed was the AC target changed from 5.6 optimum to 6.1 when they were doing the bottom lift, and as well when they were doing the county project. So the dry mix that we thought we saw during mix design was kind of proven when they got started in production. So they were almost 0.5% higher on their asphalt content once they were running in the field. And we thought that this change would give us better variability on our cracking tests. So they actually started paving the test sections on September 16th. They paved what we call sections 5 through 8 for the first 3 days, which included the 58S minus 28 binder. You can see our percentages there on the screen. We're all about 0.5% higher on sections 5 and 6 than mixed design. Section 7, we decided to back off from 0.5% higher to 0.3 higher because of some of the rutting that we saw when we were placing section 6. We backed off a little bit on section 7. You can see the air voids there are about what we would have expected. We would have been looking for 2, 3.5, and 5, something like that, for a range between sections 5 and 7, and that's about where we were. Some observations from sections 5 through 8. There was rutting occurring mostly from the rollers while paving sections 6 and 7. The roller operators try to do a nice job and making a nice smooth pavement, and they were definitely leaving marks as they were rolling these two sections. So the roller operators were not happy with the surface. We heard about that, but we kept telling them that this is a test section and this is what we're trying to build out here. They eventually, by backing their rollers off behind the paver a little bit, were able to get the mix compacted and smooth out the marks that were left in the pavement. So this is part of the reason why we backed off that section 7 and went to a plus 0.3 instead of a plus 0.5. We felt that we would have too much rutting if we would have went to the full plus 0.5 on that section. So test results for these sections. We ran these tests in our lab in Bismarck, as well as NCAT was running tests in their mobile lab out at Sterling. So the ideal CT, you see the range there, 55 to 134. The mix that was brought back to Bismarck was long-term aged for 20 hours. The mix that NCAT tested in their lab was just reheated up to compaction temp. So that's why you see that top end is a little higher for the NCAT tests as opposed to DOT, because that long-term aging will bring down those cracking results. Same thing with the ideal RT. We do not age that, but that mix was further along by the time the DOT tested it, as opposed to NCAT, who was grabbing that mix off the road, reheating it just enough to get it to compaction test, and then running those temps. So they don't see the effects of asphalt absorption and some of the effects of lag and dwell time that we see when we bring that mix back and let it sit for a few days. And the Hamburg wheel tracker results were somewhat similar to mix design. We did have one test, which was section 7, the highest asphalt content section, that hit the 12.5 millimeters at about 9,300 passes. So this matched pretty closely with what we saw in the field, especially with those two sections, number 6 and number 7, that had the optimum and the higher asphalt content. So the remaining 4 sections were paved a few days later. Those were the sections that included the polymer modified binder, which is the H-34. Those sections were about 0.4 higher in asphalt content for section 2, which was the optimum. They had backed off of their optimum asphalt by about 1/10 by the time we started paving these. That change was made based on the air voids that they were getting when they were sampling mix and testing. And as you can see, section 3, which is the higher AC content, was only about 0.2 higher. Some observations from these 4 sections. There was definitely a different type of mix or a different look to this mix than there was in the other 4. There was no significant rutting in any of the sections. The roller operators were happy. They weren't leaving marks as they rolled this material out. We did back off that optimum plus section to 0.3. The actual from what we shown at the plant was closer to 0.2. And one other thing I'll note here is that the 58H-34 was tested in both our NDDOT binder lab and NCAT's binder lab. And that asphalt actually graded at a 58E-34, which is 2 grade bumps higher than what was specified in the plans. So E stands for extreme traffic. So this material had more polymer in it than we would have expected with a typical 58H-34 project. Test results from these 4 showed ideal CT range of approximately 50 to 200 for North Dakota DOT and 91 to 220 for NCAT. Again, the North Dakota DOT testing was long-term aged for 20 hours. The NCAT mix was just reheated, so that's why there's some difference in those numbers. And the same with the ideal RT, the mix that North Dakota DOT tested had a little bit of lag time before the samples were made, whereas the NCAT samples were reheated and made immediately after sampling. Hamburg wheel tracker, similar results to the other 4 sections. Rut depths were 2.9 on the driest mix, and we hit the full 12.5 millimeters on the higher asphalt content mix at about 13,000 passes. So in summary, for the balanced mix design testing, our cracking variability was much greater during production than what we saw at mix design. We had 38 to 74 on the ideal CT at mix design. That went up to 49 to 220 during production, which is a range that shows a lot of variability, and that's what we're looking for with this project. This project is meant to show differences between these 8 sections when it comes to rutting and cracking, to try to validate that these rutting and cracking tests mean something when compared to field performance. So we wanted to have a higher range of variability with this project. And the rutting variability was much like mix design. We had good variability, but we didn't have any catastrophic results that we would worry about this road coming apart on any of them sections. So I think we were happy with how that turned out. And we worked very closely with the contractor on this project. The contractor was Border States Paving out of Fargo. And we communicated quite often with them on what the plan was for each day, paving test sections. We communicated about changing that upper end of the asphalt content. And I think in the end, we had a very successful project for what we were trying to do. In the picture are all 8 sections, the Hamburg wheel tracker specimens, both at mixed design and what we got in the field on the project. So you can see some definite differences between them, and that's what we want to see with a test section project, is some variability and some difference in the results that we get. Some other things that happened on this project that I'll just mention. It included longitudinal joint with a notched wedge. So that's something that our contractors do in response to our special provision on longitudinal joint density. They did e-ticketing on this project. We had a ride spec on this project. We had an SP for full depth reclamation with cement treated base. We had the SP for intelligent compaction and for paver mounted thermal profiling. Some of the other technology that was used on this project was the DPS was run. GSSI, who manufactures the GPS that we use at North Dakota DOT, or the one that we have, was on the project and brought out some different prototypes of equipment that they've been working on, which you can see on the left side there. So they had a roller mounted DPS unit. They also had a receiver hitch DPS unit in the top center there. We also had Minnesota DOT that brought their ground penetrating radar out for scanning. That's the bottom left picture. We did some comparisons with nuclear density gauges. That's the center bottom picture. We had a pavement marking or centerline marking robot that was used by the contractor. That's the picture in the middle. So that went down the road and marked centerline ahead of the paving. We had semi-autonomous rollers on this project where the roller could set it to run auto. The roller's still sitting on there, so it was only considered semi-autonomous, but they could have the roller basically be operating by GPS. And we had the PaveWise weather stations that some contractors use across the state. So this helps them with tracking weather conditions and optimizing when they would need to turn their plant off for weather, and how they would be able to accurately predict temperature and wind, which helps with their rolling patterns. So I need to give some acknowledgements for this project on 14. So I talked about Border States Paving. They were our prime contractor and paving contractor. Aaron Swan Lab, they did the mix design and they did all the QC testing on this project. PaveWise was involved with this project, both with some of the work we did on DPS, but they also worked for the contractor with the weather station and helping set rolling patterns. The Bismarck District administered this project for North Dakota DOT. NCAT brought their mobile lab up and they helped us in setting up this project. And at Materials and Research, we had a lot of help from both our pavement section and our bituminous lab. We went out and watched several of the test sections being built. We brought mix back to our lab, and our lab technicians and the asphalt and binder lab did all the work as soon as they could to get us results, so we kind of knew where we were at. So I need to give a big thank you to all the people on the screen here. And with that will end my presentation. So I'll just say thank you for tuning in and hearing about what we're working on at North Dakota DOT, and say thank you for attending the technical certification program classes.